applications, the operating system, and processes work. So let's first run through some of the technical definitions of processes and threads. When you look at an application and how they're actually built from, you will actually find one or more processes. A process is a program that the system is actually running at a specific time or at all times. Each process provides the required resources to execute a program, and also a process is made up of one or more threads, which are the basic unit an operating system will assign resources to. A thread can be executed during any part of the application runtime, including being executed by another thread. Each process starts with a single thread, known as a primary thread, and then they can also create additional threads from those threads as well, right? So in a hierarchical way. For example, the calculator application could run multiple processes when the user enters numbers to be computed, such as the process to compute the math, as well as the process to display the answer, right? So, regarding threads, think about threads as each number being called while a process is actually doing the computation that will be displayed by that application, in this case the calculator. So here I'm actually showing the application, the calculator application in Windows, and how it's actually shown as a running process in the Windows Task Manager, right? So process can be grouped together and managed as a unit, and this is actually called a job object and can be used to control attributes of the processes they're associated with. Grouping processes together simplifies impacting a group of processes, since any operation performing a specific job object will impact all associated processes. A thread pool is a group of worker threads that efficiently execute asynchronous calls back for the application, right? So this is done to reduce the number of application threads and to manage the work threads, right? Or the worker threads. A fiber is a unit of execution that is manually scheduled by an application. So that's another concept called a fiber. So now that we actually have covered how applications function, let's look at where they are installed and how they are run, right? So computer memory is a physical device or a physical hardware capable of storing information in a temporary way or a permanent state, right? So memory can be volatile or non-volatile. Volatile memory is a memory that loses its content when the computer or hardware storage device loses power, right, or is rebooted. Now, RAM is an example of a volatile memory, since you will never hear people say that they actually will save something to RAM, meaning that it's designed for applications performance and to actually execute programs and to help the CPU execute those programs, right? So you may be thinking that there's not a lot of value for the data stored in RAM. However, from a digital forensics viewpoint, the list that I'm actually showing here includes data that could be obtained by investigating the RAM, and it can be extremely useful whenever you're doing digital forensics, right? So to be clear about a few, of these bullet points that I'm showing here, you may be questioning, okay, so what is the relevance? One of the things to highlight is that, data in some cases can be encrypted, of course, right? So, and for the data to actually be encrypted, it actually needs to be unencrypted, right? So whenever you use it, this means that in some cases, data, things like even passwords, can be in an unencrypted state in RAM, right? So that's why, in some cases, actually, you can even obtain, information that, in other ways will be encrypted, but in RAM will not, right? So, and the listing here, of course, includes, other things like running processes, the passwords that I just mentioned right now, so any type of unencrypted data, instant messages, executed console commands by administrator, right? So, history of commands that perhaps was executed in the system, and open ports. And one thing to highlight is that this is not only applicable for Windows-based forensics, this is actually applicable for any type of operating systems, right? So for Linux, Mac OS X, Android, Apple iOS, Cisco iOS, infrastructure devices such as, routers and switches and firewalls, all these, applies, right? So now memory can be managed in different ways, right? This is referred to as memory allocation or memory management, right? Static memory allocation is when a program allocates memory at compile time, right? And also a dynamic memory allocation is when a program allocates memory at runtime. Memory can be assigned to blocks representing portions of allocated memory dedicated to run a specific program. So a program will actually request a block of memory, and then the memory manager will assign that block of memory to that specific program. And whenever that program, completes whatever it's designed to do, the allocated memory blocks are released and available for other processes and other programs to actually use them, right? Now that you have learned this concept, let's also learn what are stacks and heaps. A stack is the memory set aside as a scratch space for a thread of execution, right? And also a heap is a memory set aside for dynamic allocation, meaning where you put data on the fly, right? So unlike a stack, there isn't a lot of enforced patterns to the allocation and the allocations of blocks from the heap, right? So with heap, you can allocate a block at any time and free it at any time. A way to compare stacks and heaps is that stacks are best when you know how much memory is actually needed, while actually heaps are better for whenever you don't know and you need this to be allocated in a lot more dynamic way, right? So you don't know how much data you will need at runtime, and if you need to allocate a lot of data, then memory allocation actually happens a different way. Another thing to highlight is that memory allocation happens in hardware, in the operating system, in programs, and also in applications, right? There are much deeper concepts for understanding how Windows allocate memory, but we will touch just a few of them. This level of detail is actually not required for the exam, but I want to provide you as much detail as possible so you can understand the basic concepts of forensics, right? So let's start with a concept called virtual alloc, right? So virtual alloc is a specialized allocation of the operating system virtual memory system, meaning that it allocates straight into virtual memory while reserving blocks of memory, to be allocated somewhere else, right? There's also heap alloc, right? So heap alloc allocates any size of memory that is requested, meaning it actually allocates on the default, right? Now, again, to highlight that heap is a general term used for any memory that is allocated dynamically and randomly, right? So in other words, basically memory allocated out of order. The memory is actually typically allocated by the operating system, with the application calling the specific API functions to do this allocation. Now that we have covered some of the basics of what makes up applications and how they use memory, let's actually take a look at another concept called the Windows Registry, right? So basically anything performed in Windows refers to or is recorded into the registry, right? So a formal definition for Windows Registry or Windows registration will be a hierarchical database used to store information necessary to configure the system for one or more users, applications, and hardware devices, right? So some functions of the registry are to load device drivers, also run the startup programs, set environmental, variables, store settings and operating system parameters, right? So you can view the Windows registry by typing the command regedit, right? So here I'm showing the registry editor in Windows. The structure of the registry is like a structured file system, right? So the left-hand folders start with the 5 hierarchical folders called hives, and they will begin with the term HKey, meaning, to handle a key. 2 of the hives are real locations, which are HKey_users or HKU, and HKey local machine, right, or HKLM. The remaining 3 are shortcuts to bridges within the HKU and HKLM hives. Each of these main hives are composed of keys. These keys actually contain values and also sub-keys, sub-values, right? So values are the name of the specific attributes pertaining to the operation of the operating system and applications within a key. Now, a way to think about the Windows registry is comparing to an application containing folders, right? So inside of an application, inside of folders, those actually hold files that are then executed. So inside the Windows registry, the hives hold specific values to be used by applications and by the operating system. Now here I'm actually showing the function of the 5 hives within the Windows registry, right? So start from the top, HKey_classes_root or HKCR. It includes information that makes sure that the correct program is actually open when it's executed. The HKey current user contains configuration information that any user who is actually currently logged into the system, will store, including the usage folders, screen colors, control panel settings, and several other configurations, right? So the reference location for a specific user is HKey_users, right? So now HKey current config stores information about the system's current configuration, right? So we also have the HKey local machine, like we mentioned before, and it actually contains machine hardware specific information that the operating system will actually run on, right? So this includes a list of drivers mounted to the system and generic configurations of installed hardware and applications, right? And also we have HKey_users, which contain configuration information of all user profiles on the system. This includes and relates to application configurations and virtual settings as well. Another important concept to learn about Windows architecture is what are handles. And this list that I'm showing here includes the key handle concepts, or the concepts of what are actually handles, right? So a handle is an abstract reference value to a specific resource, and they actually hide the real memory address from the API user while permitting the system to actually reorganize physical memory transparently to the program. A handle can not only identify value, but also associate access rights to the to the specific value. Now, a handle leak can occur if a handle is not released after being used. Now, another important concept to learn is what are services, right? So Microsoft Windows services are run-learning executable applications that run in their own Windows session, right? So the Service Control Manager is the entity that enforces the rules and protocols for Windows services. Now, services are ideal for running things within a user security context. Also, starting applications that should always be, run at runtime, for specific users, and long-running functionality that doesn't interface with, other users who are actually working on the same computer. Windows administrators can manage services using the services snap-in, or the sc.exe, or the Windows PowerShell as well, right? So now the Windows Event Logging Service records events from many sources and stores them in a single collection known as the event log. Now, event logs typically maintain 3 event log types, which are the applications, systems, and security log files. The event viewer can actually be open to view these logs by simply searching for the event viewer at the Run tab. Here I'm actually showing an example of viewing logs in the event viewer. The panel on the left shows the application, system, security log categories, while the panel on the right shows actually the actions, right? So a few things to highlight in here is that logs are records of events of what actually happened in your computer, right? So the most common place for Windows logs is the Windows event log, right? So now within the log types are generally 5 event types, which are error, warning, information, success audit, and failure audit, right? So there's a concept of a log parser, right? So a log parser is a versatile tool that provides universal query access to the text-based data in a specific log, right? So that's, in some cases, actually, logs can be not only cryptic, but they can be extensive. So a log parser, can be a very versatile tool to actually provide that universal query access to the text-based data in your system. SecFun exam, you learn that a process is a program that the system is actually running at a specific time, right? So each process provides the required resource to execute a program. A process is made up of one or more threads, and threads are the basic unit of an operating system that allocates a processor time to, right? So a thread can be executed during any part of the application runtime, including being executed by another thread. Each process starts with a single thread known as a primary thread, but you can also create additional threads from any of its threads as well, right? So processes can be grouped together and managed as a unit as well, right? So this is called a job object and can be used to control attributes of the processes that are associated with, right? So grouping processes together simplifies things, since any operation performed on a specific job object will impact all associated processes. Now, a thread pool is a group of worker threads that are efficiently executing, processes, and functionality, in asynchronous ways, right? So that's called asynchronous callbacks for the application. And this is done to reduce the number of application threads and to manage the worker threads, right? So there's another concept called a fiber, and a fiber is a unit of execution that is manually scheduled by an application, right? So threads can schedule multiple fibers. However, fibers do not outperform properly designed multi-thread applications, right? So now it is important to understand how these components all work together when developing applications, and then of course later securing those applications, and also to understand these type of concepts so you actually can perform cyber forensics in case of a security incident or an attack, right? There are many threats to applications and, of course, many vulnerabilities that could be abused to change the intended outcome of an application, right? This is why it is critical to include security in all stages of developing applications and systems to ensure that these and other application components are not abused and not attacked, right? The list that I'm showing here highlights the processes and the threat concepts that we actually cover, right? So a process is a program that the system is running and is made of one or more threads. A thread is a basic unit an operating system allocates a processor time to, right? So a job is a group of processes and a thread pool is a group of worker threads. So while performing forensics investigations in Windows or any other operating systems, you should look for orphan and suspicious processes or suspicious services on the system, right? So malware could create processes running in your system to execute specific things, right? So to create users, to steal data, to corrupt data, to spread itself, to communicate to a command and control box, right? So all those are examples on how, malware can actually initiate some type of process to actually, do some harm. Now, memory management is another topic that you actually have to become familiar with, right? So memory can be managed in different ways. And this is, referred to as memory allocation or memory management, right? So static memory allocation is when a program allocates memory at compile time. So that is done, of course, just like the word says, in a static way. Now, dynamic memory allocation is when a program allocates memory at runtime, right? So memory can be assigned to blocks representing portions of allocated memory that is dedicated to a running program. Now, a program will request a block of memory, which the memory manager will assign a block of memory to that program, right? So when the program completes whatever it's actually doing, the allocated memory, a block goes back and is released and available for other, programs and other processes to actually use that memory, right? So a stack is the memory set aside as a scratch space for a thread of execution, right? So a heap is another concept that you have to become familiar with, right? So a heap is memory set aside for dynamic allocation, where you put data on the fly, right? So unlike a stack, there's not enforced patterns to the allocation and deallocation of blocks in the heap or from the heap, right? So with heaps, you can allocate a block at any time and free that block at any time. Stacks are best when you know how much memory is actually needed, while heaps are actually better whenever you actually don't know how much data you will need at runtime, or if you need to allocate a lot of data and, of course, in a dynamic environment, right? So memory allocation happens in hardware, in the operating system, in programs and also in applications, right? So there are different approaches on how Windows allocates memory. The ultimate result is actually the same. However, the approaches are slightly different. The first one is virtual alloc, right? So virtual alloc is a specialized allocation of operating system virtual memory, meaning that it actually allocates straight into virtual memory, and doing that by reserving blocks of memory at a specific time, right? So now typically it is used for special purpose type of allocation, because the allocation has to be very large, and then it also needs to be shared and needs to be at a specific value, right? So now allocating memory in the virtual memory system is the most basic form of memory allocation, in Windows. Typically, virtual alloc manages pages in the Windows virtual memory system. Now, Heap alloc allocates any size of memory that is actually requested in a dynamic way, right? So it is designed to be very fast and used for general purpose allocations, right? So heaps are set up by virtual alloc, and they're used to initially reserve allocation of space from the operating system, so from Windows. Once the memory space is initialized by virtual alloc, there's different tables, lists, and other data structures that are actually built to maintain the operation of the heap. Now, heaps are great for smaller objects. On the other hand, due to having a guarantee thread allocation, it can actually cause performance issues in some cases. So now there's also the concept of malloc, right? Malloc is a standard C and C++ library function that allocates memory to a process during a runtime, right? So during the C or C++ runtime. Using malloc will usually use one of the operating system's API to create a pool of memory. And this is actually done when the application starts running, and then allocates from that pool, right, as there are malloc requests for memory, right? So malloc, has the disadvantage of actually being runtime dependent. It is important to note that malloc is actually part of a standard, meaning that actually it's portable, while the Windows implementation, Heap alloc, is actually not portable. So it is actually a Windows specific API function, right? Now, another program-based memory is new. New is a standard C++ operator that allocates memory and then calls constructors on that memory. New has the disadvantage of being compiler dependent and language dependent. That unfortunately, causes that other programming languages, can actually not support new, right? So it's actually used mostly in C++. Now, one final programming-based memory allocation is the CodeTask memalloc. And CodeTask memalloc has the advantage of actually working well either in C, C++, or Visual Basic. Now, this, of course, will not be important to know for the exam, but the goal is actually to have a general understanding of how memory allocation works, so you have an understanding whenever you're actually doing forensics investigations for cybersecurity incidents, right? Now, the list that I'm actually having here summarizes, the key memory allocation concepts that I mentioned, including volatile memory, non-volatile memory, static memory allocation, dynamic memory allocation, what is heap, what is the stack, virtual alloc, heap alloc, of course malloc, new and CodeTask memalloc, as I mentioned before. So again, this is a summary for your reference here.